Okay, so in this video, we're going to be looking at a definite integral question. And you'll see that it's going to be pretty complicated, but once we think about it critically, we'll realize that it's super easy to solve. So the question is, let's evaluate the definite integral at 3, 3. So these are the lower and upper bounds of integration. They're both equal. And the function is, let's say, cosine x plus sine x over 2 minus 3 times sine x over cosine x plus 5. This is dx. So this is super crazy looking, all right? This is like, super crazy, right? So let me just tell you that it's not as hard as it seems. You might even know how to solve it already. So first, let's just split it up, and you don't even need to do this really, but let's just split it up so we can recall the sum and difference rule. So sum and difference rule for integration, we'll split this up into the definite integral evaluated 3, 3 for cosine x plus sine x over 2, and then minus dx minus the definite integral evaluated at 3, 3 for 3 times sine x over, and this is not minus, by the way, this is times, cosine x plus 5 dx. Okay, so now that we rewrote it, really we didn't have to, but we just rewrote it, that's fine. We can use a rule that I covered in a previous video. If the lower bound, let me color this, if the lower bound and the upper bound are equal, right, in this definite integral, and they are, if they are equal, and even in this case they are equal, we know that this whole expression is just going to evaluate to 0, right? So a definite integral where the upper and lower bounds of integration are equal, the answer is just going to be equal to 0. So this is just 0. This whole thing, no matter what, is 0. And the reason why is because once we find the antiderivative of this and evaluate it at 3, and when we subtract that for the antiderivative evaluated at 3, once again, anything minus the same thing is equal to 0. So this will be cosine, not cosine. This is going to be the antiderivative of this, which I don't want to find right now. This is the antiderivative of this minus the antiderivative of this evaluated at 3. So some x minus the same x is going to be equal to 0. That's why. So just to recap right there, this is 0. Same exact reasoning with this. This is also going to be equal to 0. And so 0 minus 0 is, well, just 0. So you needed calculus to solve that. So 0 minus 0 is just 0. And so this whole crazy looking thing, right, this crazy looking problem is just equal to 0. And notice that we didn't even have to do this. We didn't even have to split it up. We could have just realized that this is a problem involving the definite integral and where the upper and lower bounds of integration are equal. So this is just going to be equal to 0. We could have done that early on. But anyway, that's how you solve it. So this has been an example of solving a definite integral when the lower and the upper bounds of integration are equal. I hope you found this video helpful.